Good evening, Sophie.
Good evening. So then, are you able to see my screen?
Yes.
Okay, thank you. So we have, so yeah, this is the place actually where we lived, right? Component, okay, this one. So common language runtime. So one by one, we will introduce and understand what, how the common language runtime, which is our environment, and how that common language runtime will helpful to actually generate a managed code. That managed code term generally introduced in a Microsoft languages only. Microsoft state that those languages which is compiled or convert through the CLR process, all those codes are called managed code. So single definition, they will introduce that whatever the language, if that language is compiled through that CLR process, that is a common language runtime process, it means that code is a managed code. So generally, first of all, we can understand the first part, the first point, that is a class loader. As we know, any of the programming languages, most of the things are the default function, default class, default namespace, or import files. So lots of all default and entry points are there in any of the programming language, from where the application start to execute your business logic actually. So all the languages provide the entry point from where the compiler will detect, okay, this is the entry point, and from where we started. So that class loader will responsible to load all the classes which is required to execute your program. So that is a basic functionality of class loader. The second part is a garbage collector. This is very important. Uh, when we are working or when we are getting any knowledge about that C and C++ before C# or before object-oriented programming language. So in the C++ or on the C languages, these are the most, that two languages, most popular languages and very high level languages, so that developer will understand very easily. So that two languages we develop and we write a program, and that program, that program consumes some memory of your RAM, I can say. So whenever the process will start, your application will start executing, it consume your memory. And as a developer, as a programmer, this is your responsibility to remove or deallocate that allocated memory from the RAM that your program will consume at runtime. So this is totally your responsibility to allocate as well as the deallocate. The allocation will be automatically whenever you run the program, but deallocation, it means removing that resource which is not in use. It is not done by that particular languages or particular compiler. It is a completely programmer responsibility to manage that memories. Otherwise, it may be a chance or it may be a possibility we only execute a program, only run the program if we execute a very high or very memory consumable program. It might occur that you lost or your program will get corrupted because of less memory, because of memory overflow. So this kind of a situation that need to be tackled whenever you develop application using C and C++ languages. But in the C# languages, because they are in the processed through the CLR process, so that CLR will provide you a garbage collector features. That garbage collector is uh, a process to allocate as well as the delocate of your memory. And even if that allocated memory, in case we want to reuse, that garbage collector will reallocate as well based on the requirement at runtime. So it's not the developer responsibility to manage the memory. It just all responsibility goes to that CLR or its component garbage collector. So that's how that garbage collector play a very important role about that memory management. So now you are free to write your program and independently think about your logics, not about the memory management part. That garbage collector efficiently handle that part. So that is the advantage of that second component that is called garbage collector. In initial, most of the interview ask that questions, what is garbage collector and how important that garbage collector play a role in CLR process. The third point is common type system. As we commonly and specifically define that type. So when we write a program, or let's say we write a simple example, suppose I want to open a notepad, or when you are writing a C++ or a C# program, any of the languages you can pick, and you have to write include studio.h. Basically, this is a C syntax, I can say. So this is in a C language, this is a header file, and this in the C languages, this main is a entry point of our applications from where our program will compile and execute your messages. Suppose I want to execute a hello message. So we have to use printf and then type whatever the message you want to display. So this is a C syntax. So in this syntax, whatever the keyword, whatever the word that you are using to write your program, all things are considered as a type. Similarly, if we're talking about the C# languages, it is very straightforward. So you have to create the class, because this is object-oriented programming language, and object-oriented programming language must have the class in the programming. And same kind of a C++, there is an entry point as well in the program. So each programming language has an entry point. So this is the entry point of C# languages. So this is a simple structure of a C# program, a basic C# program, where you just want to display some hello message. So the way of writing or the way of displaying the message is totally different, because language is totally different. All languages have its own keyword or own class or own methods to display message. So that C# will provide console.writeLine, and here you can type your message. So this is a C# syntax. This is a C++ syntax. So common type system is a whatever the things written in the C# languages, all things, which is including that class, this a, public, static, void, main, all these is a part of a type, common type system. All the data types, whenever we do some arithmetic operator, we need data type like int, float, double, like that. But lots of data types are there. So this is also considered as a type. So whatever the type is available through that particular languages, because as we know, the .NET support multiple languages, and when we are saying multiple languages, each language having a different features and type. As you can see, this is the C++ syntax. This is a C# syntax. If I give you one more C++ example. So you have to write stream.h, and here if you go for object oriented, because first of all object oriented will introduce in C++. So class A, and here you can declare some of the feature. Suppose int A equals to 5 or 7, whatever, and here is the main method where you want to display value of A. So we have to create the object, and then instead of printf, the C++ use cout. So like that, cout, and here you can mention whatever the message of or value of A you want to display. Suppose this is a object. So this is the syntax of C++. So this is the syntax of C language. This is a syntax of C++ with object-oriented feature. And the third one is the example of C#. That language we're gonna learn. So this is the syntax of C#. So this is the example of 3 different languages. As you can see, each languages have a different way to write, different way to declare the variable, different way to write a message or display a message, or method to display a message. So all because .NET are saying we are supporting multiple languages. We are supporting C++ as well. We are supporting C# as well. They are also supporting Visual Basic. And if you see the syntax of Visual Basic, Daniel, if you are familiar about that Visual Basic, so if you declare any kind of a variable in Visual Basic, they are not using int, they are using integer, right? So here you can see in a C sharp, they are using int, float, but in a Visual Basic, they're using integer. So the way of declaring the things, the way of using the feature and the syntax are totally different. Then the CLR has a responsibility how they will determine which language have which type, and is that type is common or not. So ultimately, the compiler, the CLR will give a CTS, provide a feature that is called CTS, and the CTS is a total responsibility to identify is that type of those languages are common or not. If it is not common, that means that language is not support by the .NET, and it will throw a compile time error. So this is not appropriate languages, or this is not appropriate keyword or type to write in a program. So this CTS will just identify and set of rules, set of rules available to identify what types we are commonly used for all languages, not particularly for C#. If C# use int and VB use integer, ultimately for CTS it is integer 32. So if for CTS, if VB languages declare a data type integer, and the C# language declare a data type as int, and for both data type, CTS consider a type as int 32. So this is the type actually CTS considered for. It is very clear, whatever the syntax, whatever the type you are using to create or write a program, it's up to you, it's up to the language. But whenever it comes in the process of CLR, the CTS will identify, okay, you are using integer. That means for CTS, it is an integer 32. In C#, if you're using int, that means for CTS, it is integer 32. So that's why that set of rules are available in the CTS part to check that particular things. Okay. Next point, we are coming over to the process of common language specification. So this is a definition of class loader that I already explained. This is a garbage collector that I already explained. And this is a common type system. As you can see, it's clearly mentioned that the common type systems describe the data type that can be used by the managed code. CTS will define how these types are declared, used, and managed in the runtime. Okay, it facilitates the cross-language integration. Cross-language integration means that example. This is the C#, this is the Visual Basic. In C#, int is declared as int, but in the VB, this is declared as complete integer. So they will facilitate you and they will identify, okay, the language is different, the way of declaration is different, but still this is a part of CTS library. So this will very useful and helpful to identify which type you are using, or is that type is valid or not. The next point is related to that common language specification. So that common language specification clearly mentioned that the CLS stands, that is the stand called common language specification, and it's a subset of CTS. Then the CLR is another process to identify or specify the languages, which language you are going to be used. So that specification need to be there. Then after they will apply, okay, this is the C# language, then we have to use that the C# a syntax or language, a process that need to be identified. And because of that CLS process, we are able to incorporate multiple language into the .NET, because they will provide and specify for cross language integrations. As you can see, it's enabled the cross language integration because of that CLS process. If that CLS is not there, it means we can't support multiple languages. So if we can support multiple languages in .NET Framework, that means that CLS is there, and that CLS will help us to provide and restrict or define a set of rules to check is that criteria will meet or not. If that criteria is not meeting, that means that .NET will reject that language. You are not compatible with .NET. We are not going to be compile it. So that kind of check is available in CTS. The another the point is an important point, that is a common language, code access security. So that code access security is very pretty much clear. Every program that we execute or that we run on an operating system, they need some kind of a validation. Validation, what type of validation? Suppose if you want to install any kind of a software in your operating system, and when you double click on that particular exe which is downloaded from the internet, so when you execute that exe, immediately the one pop-up will appear on your screen and they will ask for the permission. Is that the correct application, or is that the application is safe? Do you want to authorize that to run? So that kind of a pop is appear in front of a screen, and they will alert you, is that the program that you are going to be run on your operating system, is a valid one or secure one? So similar kind of things need to be performed whenever you write a program, because ultimately when you write a program, it creates an exe file, and that exe file execute on your operating system. But during the programming execution or during the programming development process, they didn't ask such kind of a pop-up, didn't appear such kind of a pop-up to ask and authenticate that process. It will uh, automatically get access of that related security to that process. Yeah, this program or this code is very safe. You can allow that program to execute. So who are the responsible to get access from operating system? Okay, this is the code that is developed by C#, and that code and that exe file is safe. You can allow that executable file to execute on that operating system. So this is the code access security will perform such kind of validation. So that code access security will perform that to accessibility, I can say, to get accessibility of that particular exe get executed smoothly without asking any kind of indication or pop-up to authenticate that exe. So basically that is the role of code access security. Clear? Any doubt?
Yeah, it's no problem. We got it.
Okay. So now the next part is MSI and GIT. If anybody can ask you C# and they will ask you what is CLR, very frankly you can say, okay, CLR, if you are talking about CLR, that means CLR is a compiling environment, it's not a compiler. Then they will again ask you a cross question that if the CLR is a compiling environment, then who is the compiler of C#? Then you can instantly state that, okay, C# compiler is a JIT. JIT is actually compiler who is responsible to convert that managed code. So JIT is a just-in-time compiler. But before that JIT, we come into the JIT part. But first of all, we need to understand the MSIL, Microsoft Intermediate Languages, MSIL. That is the short form of Microsoft Intermediate Languages. So that intermediate language is very straightforward, is saying that, let me point out, this is the actually intermediate languages. So it will straightforwardly saying that MSI call a intermediate languages, common intermediate languages. So the process of a source code to manage code, how the computer will understand this program is now executable, and now we are able to understand what kind of things written in that program. So .NET having a multiple languages support, each language has its own compiler. If you use Visual Basic, there is a VSC compiler. If you use C#, there is a CSC compiler. If you use C++, there is a CPP compiler. If you use Java, there is a JavaC compiler. Each language has its own compiler as per their syntax and data types, as per their rules and regulations. And that compiler, we can't replace it. Because if you want to replace that compiler, and if you want to try to make a common compiler, it can't be possible. It is a very huge and very tedious task. So why we are go to that direction, which is not I can say targetable. So Microsoft think about that. Why not a source code? When the source code comes into the process of CLR, the CLR responsibility and its compiler responsibility is to just convert another languages, which is common for all. If the code is in C++ and the compiler is CPP, now the compiler CPP is a role to just convert that source code to MSI language. If the source code in C# and the compiler is CSC, that is C# compiler, short form is CSC. So that CSC is responsibility to just convert that source code to a MSI languages. So that is the immediate target of each and every compiler of that languages, which is part of the .NET framework. So that is the main process they will think about. We just make a compiler and instruct the compiler to just create another language that is called MSIL. And after that MSIL, once the MSIL is ready, then we will give that MSIL to JIT. Or now JIT is only understand MSIL. So JIT will not understand your source code. Even they didn't give you any kind of information. So that JIT only understand MSIL. So our target is to convert our source code to MSIL. So who will convert that source code to MSIL? Our compiler, the language compiler. If you are using C#, that means the CSC is your compiler, and the CSC is responsibility to convert that source code to MSIL. This is the approach. So the first target is to convert the source code to MSIL, and then MSIL, once the MSIL got created or generated, now the JIT is responsibility to convert and execute on your target machine and create your managed code so that you can comfortably execute your application on the targeted machine, any targeted machine. So this is a way, or this is a process how the CLR will perform making a source code to manage code. As you can see, this is the diagram. And in this diagram, we are completely understand all the process that we go through previously. This is the all common types, is everything. To summarize and to understand in a form of diagram, how the source code come, what are the compiler, how that compiler convert into the IL, that is the intermediate languages, MSIL. This is MSIL, IL. In the short form, we can also say IL. But this is a MSIL, Microsoft Intermediate Language. And how the metadata is generated. So our source code, I mean to say, this is the source code. Discard. Source code, it means this is the source code, a raw program. The raw program is called source code. This is a human readable program. So that kind of a program, we are generally give a statement that this is a source code. So this is the source code. Suppose any source code comes in a CLR process, and suppose there is a B C dot CS. So ABC is a file name. .cs is the extension of C# languages. As we know already, each file having its own extension, and based on that extension we can identify, okay, this is a PDF file, this is a Word file, this is the Excel file, or this is the CS file, or this is the C files. So based on extension we can identify which types of file this is. So this source, suppose for example we can consider as abc.cs is a source file. That source file having a source code that we want to going to be compiled. So this is the obvious, this is a CS file. That means the compiler is C# compiler, CSC dot exe. So this is a compiler of C#. Okay. Now that compiler responsibility is to just convert that source code, that abc.cs source code, to IL, and it also generate the metadata files. Metadata is nothing just about data is called metadata. Generally in terms we can say data about data is called metadata. So whatever the information we have that particular files, the same a copy of that particular same data having available in also in the assembly or in DLL files. That's why we can say this is a metadata. Data about data is called metadata. So our compiler responsibility to convert IL. Now once that IL is generated, now the CLR all components start working. The first GC will start and they will allocate the memory, whatever the memory is required. Then the CTS will start. The CTS will check what are the common types. Is that types is there or not? Is that the type is valid or not as per the CTS rules? Then they will start checking that common language specification. Is that rules and the languages is generally have a valid syntax or not, a valid or fulfill that CLS rules or not. Then they start checking that code access security. Ask computer and allow that exe file to execute without any pop-up or security alerts. So that all components start executing. Once that this validation has been performed, then they come to that GIT part. So in this process, as we already discussed, that CTS and CLS and GC garbage collector, that means memory allocation and allocations started. That means you need to provide some information to RAM so that RAM will aware what are the resources, what are the component, what are the memory you want to need at runtime. So at that CLR process, they will generate one file that is called manifest file. Manifest file. That manifest file having all the informations which is required for RAM, so that RAM will having that enough space or enough resource to provide you at runtime when your program will execute it on your operating system. So what kind of a resource and what kind of details available in manifest file? The manifest having consumed assembly version. Assembly version is nothing that the file version or program version. So if you are using .NET 4.5, that means your assembly version is 4.5. If you're using .NET 7, that assembly version is 7. So that is the assembly version that manifest file have. So that the RAM will aware, okay, now this program runs on .NET 7. If that .NET 7 is not available in your operating system, then the RAM will, or your program or your operating system will throw a message. This application will can't run in this operating system. We require .NET 7. So that kind of alert will appear. That alert you are not writing in your program. That is automatically detected by operating system, because that manifest file is available. And based on that manifest file, the operating system detect, okay, for that particular applications, if you want to run in this operating system, you require this kind of a dependencies tools need to be installed. Dependencies framework need to be installed. Then we will able to run. So this kind of information is available. That's why we put that manifest file into the RAM and provide the detailed system assembly version, so that the RAM will aware, okay, for that particular program we need .NET 7. Now the second is the public token key. As we know that each and every program which is available, which is run in the operating system, and the memory is generated, each and every memory and each and every program is unique for RAM. It's not a duplicate kind of a thing. So they will generate a unique key for each and every execution process. And that execution token key is generated and it is available in manifest file for that tracking purposes, for their uniqueness purposes. The third point is resources. Resources in the sense, suppose you are creating a program, that program needs command prompt to execute your messages or display your messages, because you are developing a CUI based application. CUI based applications means character user interface application, where we need to have that command prompt to display your message. So that command prompt is a part of operating system. It's not your program part. So you must have that command prompt working or available in your operating system. Then you will able to execute your command console based application. So that kind of a resource you need. So that is resource information will available. So that resource details are there in the manifest. The fourth point is related to the references. It may be possible in your code, you might link some document or some image that is available in your operating system and put it in some kind of a drive. Suppose you put any of the file on D drive and your program will you write a program to get that file at runtime. So operating system should be aware, or RAM should be aware what kind of references needed, so that the RAM will avail and have access to get that file to your program, and your program will able to read it. For example, if you try to read some file which is available in C drive, but that C drive is very secure drive, nobody can edit or delete anything on that C drive. And if you try to edit or if you try to delete, immediately when pop-up is appear, you can't authorize that file to be deleted. So that means that resource information is available, and based on that informations, the operating system behaves, how we can reply, how we can access the file, is that program is authenticate to access that file or not. So that kind of informations as a reference we can store in the manifest file. Okay.